Alright, so last time we talked about how Einstein and Newton had two opposing views as to what gravity was. We also talked about how Einstein considered gravity as a fictitious, pretend, imaginary, and non-existing force. Today I want to go back and recap on that, highlighting another portion of Dr. Perezguez's presentation, and then I'm going to explain the problem with Einstein's claim, which applies equally to both the flat Earth and the globe Earth. Dr. Perezguez's words are also kind of a mouthful, so bear with me as I break his words down and explain what he's talking about.
Einstein asked, hold on, what if the so-called real downward gravity from Earth is also fake? A side effect generated because Earth's surface is really accelerating upward. Now you know what Newton would say. He'd say, that's crazy. He would remind us that inertial frames are the standard for measuring true acceleration.
Alright, let's pause that there and recap on what an inertial frame is.
Now, Newton's laws can't tell you whether a frame of reference is really at rest or really moving at constant velocity, because that distinction is meaningless and simply a matter of point of view. However, interestingly, Newton's laws can tell you whether your frame of reference is really accelerating or not. Here's how that works. Take an object with no forces on it and let go of it. If it stays right where it is, then your frame of reference is not accelerating, and we call it an inertial frame.
Alright, let's continue now.
So you can only say Earth is really accelerating upward if you can identify an inertial frame relative to which Earth's surface accelerates upward. And there's obviously no inertial frame like that, right? Well, not so fast, says Einstein. Maybe there is. What about a frame that's in free fall? Think about it. If I put you in a box and drop you off a cliff, then in the frame of the box, everything just floats, weightless. The falling frame of the box behaves just like a stationary inertial frame that's way out in intergalactic space where there's no gravity. So why can't the box's frame be inertial? Well, because, Newton says, that frame can't be inertial. It's really accelerating downward at 9.8 meters per second squared. The interior just seems like 0g because the downward acceleration acts like a fake extra upward gravitational field that, from the perspective of the box, just happens to exactly cancel the real downward gravitational field of Earth. By coincidence.
Whew, what a mouthful. So speaking on Newton's behalf, he is saying that the man inside the box feels like a force is pushing him upward, causing him to feel weightless. And Newton is saying this is a fake force. The real force at hand is gravity, which is pulling the box downward. The main thing I want you to remember here is how Newton is describing this real force down and fake force up.
Really, Newton? Really? Einstein says, look, buddy, I'm just following your rules. You established the test for what an inertial frame is. Release a force-free object and it stays put. Stationary frames in intergalactic space pass that test, but freely falling frames here on Earth also pass that test if your so-called gravity is fictitious.
So here Einstein is pulling a reversal, saying if you have a fake force down and real force up, you get the same effect.
More to the point, Newton, if you're inside the box, there's no way for you to know that you're not in intergalactic space. This inability to distinguish free fall from lack of gravity has a name, by the way. Einstein called it the equivalence principle. And if you buy it, then maybe the falling frames really are inertial.
So with a full reversal, they both produce the same 0g effect. This is why it's called the equivalence principle.
If so, then it's the falling frames that establish the standard of non-acceleration, in which case, it's really the ground that's accelerating, upward. And what we've always been calling a gravitational force is an artifact of being in an accelerated frame of reference.
So here he is reinforcing his earlier claim that a falling object is actually stationary, and the ground is really accelerating upward.
There's no such thing as a gravitational force. Instead, it's more appropriate to think of the apple as stationary, and the ground, along with everything on the ground, as accelerating upward into the apple. Now, what I just said sounds preposterous and maybe even moronic, but it's not sophistry. There's something substantive here. It's really the ground that's accelerating upward. And what we've always been calling a gravitational force is an artifact of being in an accelerated frame of reference.
The word artifact here means a substance or structure not naturally present in the matter being observed, but formed by artificial means. It is any feature that is not naturally present, but is the product of something else.
It's not different from the weird backward jolt that you experience on the train that you know perfectly well isn't being caused by anything. So why are you insisting that the downward jolt we experience every day on Earth has a physical origin? Maybe gravity, just like that backward jolt on the train, is an illusion.
I really had to go emphasize all of that because a member of our debate board continued to claim that he never said the Earth really accelerates upward, and that I just didn't understand what Dr. Perez was talking about. So this is for anyone else who felt the same way. Additionally, another member of our debate board told me that I needed to stop saying Einstein and Newton had opposing views, and claimed that that was a straw man. While the effect on a falling man is the same in both models, I agree. That is why they called it the equivalence principle. But the cause of the effect is what they disagreed on, which is what I wanted to emphasize. In the Brian Cox experiment done on the BBC, Brian was found saying the exact same thing after dropping a bowling ball and a feather in a vacuum chamber and watching them both hit the floor at the exact same time. His exact words are, Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He concluded they were not actually falling, and that it was actually the Earth rising up to meet them. That is a completely opposite view. No strawmanning there whatsoever. Unless, of course, the BBC is wrong here, as well as PBS. Lucas on our debate board seems to be under that impression. But you have to keep in mind, the whole Earth rising versus an object falling, that is what you're equating in the equivalence principle. That's what it's all about. However, the big question that I find myself asking is, do they actually equate? In 0G, an object is supposed to be weightless, until an object applies force to it, causing it to accelerate. At that point, its weight is then determined by the amount of acceleration it experiences. With that being the case, if gravity were the result of the Earth accelerating upward, everything on Earth should weigh the exact same amount. For this howitzer to weigh more than me here, the Earth would have to discriminate and accelerate more against it than it was with me. But here I was standing right next to it and it wasn't moving. And if you want to get into gravity wells and all that, if I were to just simply stand next to a heavy object, I should feel heavier. But that is also very clearly not the case. That means Einstein's entire equivalence principle, that his entire theory of relativity is founded upon, is wrong. That makes me wonder who else is building on this faulty foundation. What kind of domino effect will this produce by knocking this one block over? According to NASA, Einstein's theory of relativity is critical for GPS and is seen in distant stars. Well, I think that says a lot about NASA right there. The implications of this are very much worth looking into. Thank you all for watching. Alright, Einstein's failure 2. Show me the math. Let's get started. Last time we talked about how Einstein and Newton had two very different explanations as to why things fall. Newton said a force pulls the apple down to the ground, and he named that force gravity. With that, please keep in mind here that gravity is just a name like Fred or Wilma. So for now we will just refer to it as a force. According to Newton, this force pulls the apple down to the ground. On the other hand, however, Einstein disagreed and said no, the apple is stationary and the curvature of space-time is actually causing the Earth to accelerate upwards to the apple. And since the ground and the apple come closer together in both Newton's view and Einstein's view, Einstein referred to this as his equivalence principle. But as we mentioned last time, the problem with that is the fact that they don't actually equate. This can be observed by different objects weighing different amounts without the ground breaking apart beneath our feet. While both the ground and the apple come closer together in both scenarios have very different consequences. Now let's take a look at the math. As we know, Newton's second law of motion is force equals mass times acceleration. So when Newton drops an apple, you can take the mass of the apple and times it by its acceleration, and that will tell you how much force it will have when it hits the ground. Now let's flip that around in Einstein's perspective. If the ground is rising up to hit the apple, you take the mass of the entire Earth and times it by its acceleration, and that will tell you how much force the Earth will have when it hits the apple. Since the Earth has way more mass, the Earth will hit the apple with way more force. Herein, Newton's force and Einstein's force do not equate whatsoever. Now, you might say it isn't the entire Earth, it's just a part of the Earth that is accelerating upward. But if you take just a part of the Earth, then you have the whole Earth dividing asunder and breaking apart in all directions. But that is something we very clearly do not observe. We've had a pretty extensive conversation about this on our debate board, and in it, one globe earther told me, no, it's not the mass of the Earth that you use in the equation. You still use the mass of the apple. In Einstein's view, the force or weight of the apple is still the mass of the apple times the upward acceleration of the Earth. Alright, so let's see where that line of reasoning takes us. Since Einstein claimed the Earth was actually accelerating upward while the apple remained stationary, let's refer to the Earth as a projectile. And the apple, let's refer to that as an obstacle. Now let's go and apply that to our equation. Here, the force would equal the mass of the obstacle times the acceleration of the projectile. By that line of reasoning, if I were to toss an ant as a projectile, and an elephant were to stand in its way as an obstacle, then that ant should hit the elephant with a lot of force because that elephant has a lot of mass. On the flip side, however, that reasoning states if an elephant were to get launched at an ant, that elephant should hit the ant with very little force because the obstacle in this instance would have very little mass. That is the exact opposite of what we see in reality. So this line of reasoning clearly doesn't work. So that brings us back to force equals the mass of the Earth times the acceleration of the Earth. And if that is the case, then everything on Earth should weigh the same amount, unless one patch of ground is accelerating upward faster than another patch of ground, in which case it would divide asunder. Since we see different objects weighing different amounts, and we clearly do not see the Earth splitting apart, launching heavy objects into the air, we are left with the conclusion that Einstein was wrong, and that his equivalence principle does not equate. Thank you for watching. This video was brought to you by the Flat Earth Institute of Science. And we highly recommend that you check out the Flat Earth Clock app, where you can get to know a flat earther near you.